no ads. good evening. I hope everyone's is good. Want to welcome you. Thank you, Silent, for the resub. Evo Clark, hey, welcome. I hope you're doing good. Hope you're having fun with your 3D printers. Welcome back to the stream. I hope you have your beverages ready. Everyone's kicking back. I'm sure. So let me check. There are 6 people watching on Twitch, 5 people already on YouTube. Welcome. Welcome to this little evening stream, as it's becoming a habit, actually. It's becoming a habit. So we're doing a stream about the Prusa Mini Revo upgrade. Promised you that. Last time we were talking about the Hotend, and it was, yeah, I mean, it's still working, the Hotend on the Prusa Mini, but I felt, okay, let's figure out if we can use all of the Revo parts that I have here. So let's swap out the Hotend system, so we have the Revo system from E3D. It's a bit pricey, but it is. It's really great to have it to be able to swap out to different nozzle types, right? Easily swap between different nozzle diameters, and also adding the high flow nozzle or something like a I say high temperature nozzle doesn't make sense on this printer specifically, but I want to do this in the first place because we want to push Benchys print speeds on this printer to a higher level. Last time we were able to, I think we had a 28-ish minutes Benchy, and in the meanwhile I tuned the settings. Like with the old Hotend, I was able to tune the settings in Prusa Slicer so that we are more like towards 23 minutes and 30 seconds. I think it can be potentially even faster because the printer, like, we can tune the acceleration settings and such. But most of the time, why you are going to be limited with your 3D printer in terms of actual printing speed, especially with bigger parts, is the flow rate. And that is, most of the time, it's limited by the Hotend and also the heater system. It's just not going to be melting the plastic fast enough. So that's why we're swapping out this and figuring out what's the max flow rate then after the change, and then doing a few test prints just for fun, to give this printer a little bit of a, I would say, an upgrade that makes it a 2025 worth printer. This is kind of more up to date because I still like it a lot. So let's take a look what we have here in terms of the parts that we are going to apply to this printer. So let's see. Just want to make sure that I'm turning down the volume of the music a bit more. Let me know if it's fine. I guess so. So what we got here? We got here a couple of parts. So first of all, there is the Revo Prusa Mini upgrade kit, and that consists of a few parts. You can also get a full upgrade kit that contains all the parts from the Revo system, but this one is more a reduced set of parts, which is only the cold side. This is the Hotend cooler. Right, it's the cool side. This is where the nozzle gets screwed into, and this is going to be mounted on the printer. We have a couple of cables here, so the sensor cable and the heater cable, PTFE tube. I'm gonna figure out what we actually need this for, and then we have this part which is already printed, but you can also print it yourself. This is basically the adapter part that's going to hold the cold side, and it's going to be mounted to the printer. Couple of more, like a few zip ties, 2 square nuts, and that's basically what comes with the minimum kit. That's only the cold side kit. And then we have a couple more parts here. We have a Revo 60 watt heater core. That's the high power, let's say the more powerful version, right? Because there is a 40 watt heater block and there is the 60 watt. I think it's probably not going to make an extremely high difference with the type of material that we're going to use, but we're still going for the more powerful one. It's also 24 volt, so fitting the Prusa Mini, so the more powerful heater core. And then we have a couple of the nozzles here, like a few more nozzles, different sizes, so 0.8, 0.4, 0.6, 0.25. We're probably going to use the 0.4 in the first place. All right, so there is basically that's where we're gonna compare it with the previous, with the original nozzle, just to see if there's any difference, just swapping out to this system and then using the 0.4. And then we have the Revo high flow pack, which is another set of nozzles, which are, which contain, let me see what's inside. I think a couple of high flow nozzles with different diameters. We need to check which we actually have in this kit. So there's a high flow 0.8 from Bondtech. And then we have a 0.4 high flow rapid and 0.4 and 0.6. So this is, let me see which ones are actually the high flow versions. I think these are two normal nozzles and then we have the high flow versions here. Now in the original high flow kit there's only 0.6 high flow and 0.8 high flow. What we can do to really do the proper comparison, there's actually a 0.4 high flow. So we have a 0.4 high flow and we have a 0.4 standard. So we don't need the standard. This is basically just the same one as, it's an identical one as we already have here. So we have all the nozzle diameters that we need for high flow and we have the standard nozzles. So we can test basically just a comparison between different high flow and non-high flow, to see how this affects our actual flow rate maximum. So these are the cables that we need. Probably some cables that already have the right adapters, hopefully, for the Prusa Mini. And we are going to take a look for a moment on the instructions. So this is the instructions. We're going to follow the instructions. That's the original Hotend on the Prusa Mini. And there's a 2.5 hex driver here, which we also need. And this is how it's going to look like in the end with the new Hotend. Very similar actually, just holding the Revo system here. It's, not much of a change in terms of the overall, let's say, look and feel of the whole extruder. The profile doesn't really change. It's potentially even a bit more lightweight because this cooler here, the original cooler, is bigger, and that one is definitely more compact, and it's just a plastic part instead of the metal part. So it's, from my point of view, it could be a little bit less weight, but I think this is not going to make a huge difference. So this is already coming with the kit, so we don't need to print that out. We have also this cable fixation, cable management arm, and probably all of the tools that we need should be here. If not, we can probably just get them for the workshop. So we are first getting into the disassembly, taking off most of the parts that hold the fan in place, also the PTFE tube, cable holder, and the fan disassembly, and then basically just in the end we're going to remove the cooler. Probably also have to unwrap the cables back to the main board so that we can disassemble that, but we're going to start here And the first part is actually that I need to unload the filament from this printer because it's still in, before we can actually do this. So let's have the filament unloaded. Hey Cod Wolf, how are you doing? It's been a while. It's been a while. You haven't been here for a while. It's also quite a while back when we did the last printer modification on this channel, to be honest. It must be years. Potentially the Hotend is lower. I have to figure this out. We probably we're gonna come to this point in the instructions at some point. They're hopefully gonna make some explanation about that if that's actually the case. I hope that we're not losing any Z height, but we also gained 5mm of Z height due to the IFS upgrade. So it could be that we're actually not losing anything compared to the very original Prusa Mini. Right, so the modification that is done on this printer already is a Bondtech IFS. So, because that is, like, I did this way back in the beginning when I got this printer, very early actually when I got this printer, I upgraded to the Bondtech IFS extruder for the very reason that the original extruder, I wasn't so happy with the original one. It was okay, but it wasn't pushing the filament, you know, like, I would say not in a consistent way. It was skipping a lot of times, and even like with really enforcing more pressure on the gear, it was still sometimes just slipping through with some filaments. And it is not, the original extruder isn't a dual gear extruder, so there's only one gear that's pressing the filament against an idler, and that idler, it doesn't have any gears, so it's like really just a flat idler, and like, I mean, it has this kind of groove, but it doesn't have any gears, and it's not really also additionally transporting the filament. It's just like moving alongside the filament, and so there isn't as much pressure and not as much power that's pushing the filament in. And sometimes that became an issue. And so that's why I switched this one. And the second benefit is that there is a filament sensor, or you can reuse all of the parts from the original filament sensor that is the plus of the Mini, basically. That's an external filament sensor that's like a couple of centimeters before the actual extruder. It's moved into the extruder, so it has an internal filament sensor in the extruder, and it's also more reliable. It's easier to insert the filament. Sometimes inserting the filament into the original filament sensor was a little bit, I would say, tricky. Sometimes you had a couple of times you had to figure out how to insert it so it actually gets through. And so with this new version, it is basically just flawless. Just push the filament in and it's working all the time. It's super easy. Yeah, the extruder motor or dual gear extruder is generally a good idea with 3D printers, especially if you're modifying stuff and you want to print faster. It is, at some point, it's probably something that you cannot avoid. Highly recommend that. I did this basically for all of my Ender printers. All of the Ender printers have dual gear extruder, and it's so much better. Now the next step here in the instructions, if we're looking at it, let's just take the next step. We're going to disassemble the. Probably gonna run the printer down a bit, but I think it's actually good. You can, if you hope you can see everything that you should see. Maybe let's get a little bit closer. So here is our lovely extruder. Gonna switch off power and start disassembling. According to the instructions, the first thing to disassemble is actually the cooler on the part cooling fan. So we should get this disassembled. Let me see if I can bring this full screen on prompter. Yeah. Okay, so first step is getting the cooling fan disassembled or unmounted. So we can reach another screw that's holding the whole Hotend cooler. Probably need some pliers. Some pliers would be great. Let me see if I got some pliers here. Maybe we need to go to the workshop. Anyways, screw number 1. The cooler is just pushed in here, I guess. I also want to loosen this cable here, because we probably have to unwrap the cable tie anyways, the zip tie and everything that's holding the cable. The cables are running in a nice, actually, cable wrap tube. I'm not sure how to call it. So it's all wrapped in a flexible tube here. Easy to get cables out and insert new cables into that. So that's what we ultimately have to do. We have to remove all of the cables. The heater cable, the sensor cable, we need to remove all of those cables from this tube here, the black one. That's going back to the main board, and we need to replace the cables with the new Revo cables. And I don't know, put stress on this cable, so I'm gonna remove this mount. And then we hopefully can tilt out. Yeah, we can tilt this out. So this is done. There is another screw right in here. In a moment we're gonna remove that. And we have to remove the PTFE tube here. This is running back to the extruder. So I'm curious how this is going to be working with the new part, because there's no actual counterpart on the new. I think we have to replace that completely, if I'm not wrong. Or we're gonna take it off. Well, we will see. Probably we have to take this off. And so the brass part here, which is like ending in the upper section here, I'm gonna have to remove that. Very, very likely. So this is done. Removing the PTFE tube. We also have removed the cable management arm. And then we're gonna disassemble the cooler, starting here with the fan, which is mounted here on the side. Hotend is still a little bit hot, so to say. It's still heated up from the filament unloading. So we have to be careful not to touch that. Screws are all the same length, which is great. So we don't have to think about which one goes where. Here is this is the part that we don't need anymore. This is going to be replaced now with the E3D part, right? So these are the two interchange parts. So I'm gonna keep this one just in case. And now the rest, or the last step here, is that we are going to take off this whole, the upper section, the throat cooling, and also the nozzle and the heater block. So all these parts together are going to get disassembled, and we're gonna put them away. We don't need them anymore. So there's actually 2 screws which are holding this. One was behind the part cooler, and the second one is up here. Now we can take this off, right? So this is the whole hot end together with all of the cables, sensor cables, and that's this part. Now the job is we need to get all of the cables out of the tube, route them back here, like trace them back to the main board, and then unplug. And then the disassembly section is done. And then we are going to reassemble everything with the new hot end. Yeah, so hope this works. This is the good part about this type of wraps. You're just a cable wrap. You're just opening it. It's just wrapping itself around the cable, so you can just remove one cable, get another cable in. It's very easy because you just have to like just open it like that, put the new cable in, and then it folds back. But I see that we also probably have to reinsert the other cables once this is done. Now the truth is it's also fixed on the extruder, so there's 2 zip ties here at the extruder. We need to replace them, and later on we're gonna fix it back to the same place. That's a bit unfortunate, but unavoidable. Creality high and the A1 comparison is what you're looking for. Yeah, this is definitely going to happen. One of the things that happened, if you remember, one of the things that happened to the Creality high, we printed a couple of multicolor prints, and then I personally I think 2 or 3 times ran into an issue with the filament sensor that's actually in the hot end or in the tool head, like at the very upper end. There is a filament sensor here, and there's also a filament sensor in this multicolor CFS system, so the AMS. And this filament sensor seems to have a kind of a temperature problem. It is always triggering. After a while, it's like triggering. It's not reacting anymore when the filament is removed. And so I had a little bit of a back and forth discussion with my partner there at Creality. We were like discussing different ideas, what could be the reason. And I was first having the impression that there would be some filament in, like some dirt or something, remaining parts of filament after the cutting process, but it's not actually the case. The actual problem is more likely the filament sensor itself. So it's probably broken, and I'm getting a new getting a replacement, and as soon as I got this replaced, then we'll continue with the testing, and I also can do the comparison with the A1 in a proper way. Now let's take a look what we do here with the cables. Currently have to unwrap the whole cable management and get the cable out. So the hot end cable together with the sensor cable. There is 2 plugs here in the main board. We want to be carefully getting the cables out, and then we're gonna unplug. Here is where the heater cable comes. So this is at the main board. There is one place where there is the heater cable inserted with a little plug. I need to actually find a little screwdriver. Where's my toolkit here? This is somewhere in the workshop. I'm gonna be back in a second. If I get the high, I'm putting the CFS on the K1C. Yeah, that's definitely something that I'm also looking forward to do. I will definitely get the upgrade kit, which can be used to put the CFS system on the K1C. I'm curious how this works. Why is this so tight? Screwdriver is too small. Okay, let's take a bigger one. Oh my goodness. Who has tightened these screws? To be honest, this is crazy. I need an even bigger screwdriver. Is it possible? Let me see. 0. What do we have here? It's not wide enough. Still not powerful enough. Don't get enough pressure on here. Actually, you probably need a screwdriver with a bigger handle, so I can get more power on this. Man, what's happening here? It's weird. It's actually weird. How is this inserted? Strange. So it's really difficult to hold it and get the screw. Yeah, here we go. This was just a screwdriver that wasn't big enough, actually. Not enough grip. Okay, so we got this. So this is the little plug that is used to secure this in place. Hope this is still working, because I kind of pinched it with my gripper. Let's see if this still works. Don't want to destroy this for sure. Okay, so it's still working. So this is the cable for the heater. So let's try from the other end to get it out of this cable wrap. Don't want to have all the cables coming out. But that's the problem, the way how it is inserted. It's probably just pulling everything else out. Don't want that, actually. Can we somehow do this without pulling all of the cables out? I'm not sure. It's kind of really like going in circles. Okay, we probably just have to do it all over again. Not sure. Guess I'm gonna pull all of the cables out now because they are kind of twisted. But it's still easier than having to push everything through, and then also have to, like, if you just want to swap out 2 cables from a usual cable protector, it's very hard to get new cables in. Probably have to do all over all the cables, reinsert everything from scratch. But with this one, it's easier. But I feel that this is very much something we have to do with this even right now. So, okay, I'm fine. Everything is disassembled now. Second pair of cables is the sensor. Also need to disconnect it from the main board. Is this a plug actually? Yeah. So let's not break it. Yeah, that's it. Fine. Okay, so we have the cables out, so the complete Hotend assembly is now removed from the printer, and all of this is getting replaced with the Revo system now. So let's keep this as a replacement if we ever need it again. I'm not so sure. Honestly, I'm not sure. And now, let's start a reassembly. So let's get back to the instructions here. MTB Match J, thank you for the follow. I missed that. Probably didn't hear it. Probably need to get at least some small speakers here in the studio so I can actually have a very low volume, but still hear when I get the alert sound. So otherwise, if I'm not wearing the headphones, I don't hear anything from the stream alerts. Creality's anniversary is coming up. Yeah, okay. See how much of a deal the K Plus. Do you have a current price for the K2 Plus? I'm not sure, like what the current. Let me check it. K2 Plus. Well, how much are they selling for at the moment? The original Creality store, 1,499 euro. So not really not a Schnäppchen, as we might say. But maybe they're gonna get the discount soon. Yeah, it's currently not really discounted, to be honest. It's like around about 1,500 anywhere. Okay, so we did the disassembly here. We removed all the cables. We took it out of the cable sleeve. Okay, now we are assembling the Okay, so we want to insert the screws into the printed part just once to probably just create some threads. Makes sense. So let's do that. So this is the printed part, and we probably want to create a few threads here just by going in and out with the screw once. It's going to be easier than later at a later stage when we are assembling everything, hopefully, once we have done this. How is it going? 2,100 Canadian dollar. I did win the Space Pi Plus last week on the live stream. So the big filament dryer. Nice. Congratulations. Was it the Creality Facebook live stream? YouTube live stream, okay. I'm just aware of the Facebook streams from Creality. It's the only streams that I really have seen so far. I didn't know that they are also live streaming on YouTube, but maybe just restreaming on at the same time. Yeah, these kind of giveaways are always really nice because you can get some expensive stuff for free. Who would say no to that? No one, most likely. Yeah, not great that they're still doing this. K2 Plus is yeah, it's probably not a bad deal. I mean, one thing that I figured out, and this is something that I also want to highlight to you, if you are thinking about upgrading the K1 or getting the Creality High, if you remember, we have been looking at the K1C in terms of the Clipper software that's running on it, and there is a script that's currently, I mean, it's not really maintained anymore because there hasn't been any updates for the K1C in terms of the firmware recently, but it still works on the K1C. It also still works on the KE and the V3, which is the Guillemot script to install Clipper, or basically just get all the mainsail or fluid interfaces available, and then also to be able to install additional features from Clipper to the printers. Now the downside with the Creality High is you can get the root login for the Creality High, but I did that and I also logged into the fluid web interface that they already have on that printer, and there is a couple of things that you cannot really modify. So for example, you cannot modify the module that is running the CFS. So you can modify a couple of things, but a couple of the features are kind of hidden away because you cannot access all of the script files for whatever reason. I think there is probably just some pre-compiled modules that they have done like they have added those to Clipper. In theory, it's fine, but you cannot completely get access to everything, and there is also no script. Probably also not required because you have Fluid running on the printer, so you don't have to install it. But there's also no script that will unlock the printer in terms of additional features. So unless someone comes and does it, and I think the creator of the Guillemot script is currently working on a K2 Plus. At least from what I see on their GitHub, they might be working on something, but it's not like guaranteed in a way that this is going to be the same experience or something. So we have to wait, I guess. Now we are in the next step. Actually, we have done all the threading part, and now we are inserting the Hotend, or the, let's say, the heatsink. Let's do that. So take a look. This is the Revo heatsink. That's the upper section of the whole system. I think we don't need the PTFE clip. Probably want to remove it before. I think it's very hard to insert it afterwards. We'll see. And this is coming in from the bottom. There's actually little threads here in this printed part. Now, one of the questions that I had regarding this, I'm not sure, but since this is now only like screwed in, like there is no other way, there's no other thing holding it, right? I'm not 100% sure how this is going to be kept in place. So is there anything else going to fixate this in position? I'm thinking about just doing some Loctite in here, right? Just getting some Loctite in here, so it's at least a little bit harder to unscrew. the question is, I think where it's coming from is actually what happens if you have the nozzle in. Maybe let's take the 0.4. So if you have that nozzle screwed in here from the bottom, and now you wanna like unscrew it, and it's maybe very much tightened in place. I don't know. And then we want to unscrew it, and we might loosen the, I'm not sure if it's potentially going to get loose. Probably not. Maybe not. Maybe not. It's maybe fine. I'm not sure. We can see that later. We can try it. Could still do some Loctite in here if it's potentially releasing. So this is in place where it should be. And now we have the heater core. And then also the nozzle. So the heater core and the nozzle come like basically are like inserted this way. So we just have the heater core, like there's a little spring that you can use to attach it to the bottom part of the cooler. And if it jumps over, so once it's attached, I think it's gonna be holding itself in place. I'm not sure. Should be possible. Ideally, it's going to clip on, yeah, like this. So now it's hopefully like, oh, we can't see that. Okay, so this is the heater core, and the heater core is basically just mounted to the bottom of the cooler, to the heatsink, and you just screw it on, right, like that, and the spring is going to attach to a little a small thread that's at the very end of the heatsink. So now it's not gonna come off, and now the last part that you can do here is just easily just push the nozzle through and then screw it in place. That's fairly easy, and then it's gonna push a little bit on the spring, and then it's done, right? So it's now mounted, everything is together. All the three parts are connected and don't move anymore. Yeah, I guess now we can start assembling this to the printer. It looks nice, yeah? Looks very, very compact. Let's see how it works. So we have two cables coming with the upgrade kit. These two cables should be working with the Plus or the Mini's main board. There's two connectors here. I think what we have to do is, actually we can connect the cables right now, and then we should be able to just connect them to the main board. I think that we have to kind of wrap the connector together with everything else into the sleeve, right? Not sure, is this the right cable? Yeah, this is the right cable. So this is the heater cable, and this is the black one, and the white cable is the sensor cable. So these two cables, we have to wrap them together with these kind of a little bit clunky connectors. We have to wrap them into the sleeve. I hope this works. Hope this is not gonna cause any huge bulky part here, but let's see. Okay, what does the instructions tell us here? I think it's basically just mounting this back to the printer. Cut the tube above the brass. Is this not removable actually? Okay, with the Revo micro secured, now we must reattach the broken tube. You can cut the existing tube as shown here, but you may wish to use a fresh piece of PTFE tubing if you have some spare. I mean, yeah, there's these two options, but I think the PTFE tube is still fine, right? So It's probably not something we need to do ultimately. So let's just try to get this brass thingy off. Is it pressed on that? It's not going to come off. I'm not sure. Is this maybe the whole secret? Is this not coming off? It could be that they have, that Prusa has pushed this over the PTFE so it doesn't come off. Not sure. Is this only moving in one direction maybe? It's actually not moving anywhere. So wondering how they got this on in the first place. Is there a special way to push this on? I'm not sure. Is it possible to push it off? Probably not so easy, huh? So maybe we just need to cut it as they suggest to do. Trying my best. So I'm cutting off the least amount. Hope this works. Okay, so we didn't lose that much, but honestly, I don't know how they are actually pushing this brass part on. It's not really clear. Sever. Probably there is a way to do this. Difficult. So, gonna figure this out. It's probably not the best invention ever made. Now, here comes the Hotend. Without throwing off anything from the table, so we have to assemble this now. Let's see where the cables have to go. Which way do we want to have the cables going? Probably to this side here. And seems to be a fit, but how is the cable path actually? Is it going here? Not 100% sure how they want to have the cables going. Is this going to the back under the printer? Probably yes. It's probably just this way. Okay, so it's going to be this way. Fine. Should be fine. So let's attach the first screw. The first screw is the one that is coming from the top side, like the top screw is going through, and there is a mini square nut that is pushed in here in this tiny slot, holding the first screw, or getting the first screw attached. Okay, this is working. Now where is the second slot? I didn't catch that, to be honest. They never mention where we have to push that in. Probably on the other side, is it? Good question. Where does the second square nut come in? Maybe I missed that. Maybe I missed that. Let me get this off one more time. Just figuring out what the second slot for the square nut is. Here, down here. So it is the tiny slot here. So I hope this is not going to fall out. Okay, let's push. It's just happened. It's not really fixed in place. Probably need some tape to do this, but I'm gonna be careful. Maybe I can get it done without having the nut falling out. So number one. And number two. We are good. So this probably shouldn't. This shouldn't move anymore. It's done. It's in place. And now, like I think that the tedious job to do is now getting back everything in place, all the cables back into the tube here, the shrinky part, attaching the fan. And putting all the screws back into place. So let's do that. Number one is coming here from the side. And there's a second one up here, if I'm not wrong. Yeah. Just making sure the fan is in the right orientation. So it's pushing air from this side, pushing it in and pushing it through. So it hits the cooling part. I'm gonna show the result in a second, so I'm gonna take a look at the final assembly. But you see, this is just, I mean, it's very simple to do actually. There we go. So, getting there. "3D Snafu saw the Creality video for co-print that looks nice too." Co-print? What is co-print? I'm not sure what you mean. Didn't see that. Creality video for co-print. Let's figure out what that is. Is this an upgrade that's not from Creality, right? So let's take a look. So what is co-print? I'm curious. Is this another upgrade that will basically just get you multicolor printing on an Ender 3? Let's see, what's actually happening here? Removing the tool head, nice one. Plug in the chroma head. Let's jump to that. Is this a complete new Hotend for the Ender 3? Okay. Yeah, likely. They probably have to have a filament cutter in this. This looks chunky. My goodness. Pretty chunky. Pretty heavy. Oh my goodness, such a big thing. Oh my goodness. Curious what they can do with this. This is definitely not for high-speed printing. 8-in-1. Goodness, you're kidding me, right? 8-in-1. Okay, that's crazy. An 8-in-1 adapter, my goodness. Oh man, this is crazy. This is crazy. So what's happening now? So we have 4 extruder motors here. Probably if they have 8 inlets, probably you can also go for 8 at some point. Okay, so you need to cut the PTFEs yourself. Okay, I see. So you're doing this for all of the different extruder motors. I see. Okay, there are 4. I see. So there's probably no filament cutter then, because you have 4 independent motors. You probably don't need a filament cutter in the tool head. Most likely not. Okay, so it's likely that's probably clipper, yeah. So you're clipperizing your printer, you're losing the original screen, I guess. And instead you're using this new screen. Okay. Sounds like a plan. I guess. Yeah, so 4 spools running to 4 extruder motors, and the way how they do this is likely you just have a huge purge block and no filament cutter mechanism and no like additional purge coming out of the nozzle, except the whole the purge block. Looks nice. Looks nice. Probably this is going to work on any printer, or most likely any printer, because it's a complete swap out for the Hotend, right? Yeah, nice one. Nice idea. Probably quite a few people are gonna go for that. They wanna go for multicolor. Why not? So we have done the cutting. Okay, so we don't all squash this. This is why I'm not using a cutter knife. I'm just using this useful little PTFE cutter, which is gonna make sure that you're actually going in perpendicular, so you're really making clean cuts. It's very cheap, actually. Get it on Amazon. Super cheap part. Just very easy to do PTFE cuts with this. Good. We're pushing in the PTFE. And then we're doing the wiring, I guess. Yeah, that's the tedious section. Okay, let's do it. Let's do it. So putting in the PTFE here. Is it actually still long enough? Yeah, just enough. Just enough. It's just fine. We shouldn't have it shorter. So I mean, it's bending a little bit. Probably we should think about replacing. I'm not sure, but for now, I'd say it's fine. It's probably fine. Yeah, I mean, I think this is okay. Good. So what next? We are going to route the cables. But how? Good question. How are we doing this? In which direction do we want the cables to go? Probably this way up. Just right here. Is there actually some diagram how this is done? I had this on my Mini that got a blob of death and destroyed the ceramic heater. Yeah, that's not nice. By the way, like avoiding the blob is probably one thing to avoid the blob is to get some, how is it called? There is some paint. I think it's plastic repellent paint. And I got some here, so we're probably gonna attach that, like probably gonna apply this kind of paint. So plastic repellent paint, you can put this on the nozzle tip, and that is basically making sure that at least less filament, less plastic is going to stick to the nozzle tip, right? So if you apply this carefully around, and the Revo system has a little bit of a higher surface there, so it's a little bit more surface area that could potentially grab the filament or drag the filament. And by applying this like plastic repellent paint, you can most likely avoid a lot of the problems. And yeah, we'll definitely have to do this for, especially for the higher flow. But how are we going to continue from here? Let me see. So we have this little clip here. We want to insert this clip. So securing the PTFE. It's not gonna jump out. So fixing that in place. And the wiring. How are they doing the wiring? Is this maybe, do we have to go underneath the plastic? Yeah, maybe. I think there was a comment talking about that. Is there actually enough room for this? Yeah, there might be enough room to run it here through this little gap here. Yeah, there's probably enough space there. As it was in the original, it was also coming out of that little tiny slot. Let's try that just by taking the fan and we're going to tilt it. So let's run the cables right here. Is it still possible? Yeah. So we can get the cables through this little gap here. Okay. That's actually how it was before. I was just wondering how it's done, but I'll show it to you. So the idea is, or the most important thing is that it doesn't actually get in the front of anything that's moving. So here we go. This is the way how we do this. Cable is coming out right here next to the sensor cable, and now we have all these, with these 3 cables here that we are going to have to insert into the, like actually a number 4 is the cooling fan cable. And this one here. Yeah, kind of twisted everything now. So let's untwist this whole cable tree. Don't like that. It's making things very difficult, to be honest, if the cables are twisted that much. If you ever need to swap out anything, it's really difficult. Okay, got this one free. So maybe it makes sense to disconnect every cable. Not sure. Or maybe it's even better to have every cable disconnected in the first place, and we start all over, like putting this together. At least here at the top section, there's so many cables. Okay, so let's attach the blower fan, last thing. And the cable management, I mean, this is last part. But this blower fan, we need to secure that by using this one screw that goes here at the top. Come on. So going through. Not sure. Anything blocking? No, hope not. Are we ending up at the opposite side screw? I hope so. the moment I don't see this to be working. Don't work. Why? Why is it not working? It's not locked in correctly, so maybe that's the case. That's the problem here. Fan isn't really sitting in the slot correctly. I'm thinking of getting a Revo again for the mini YouTube print with 0.2. Yeah, maybe. Thank you, Zarent, for the tip. I guess cable is now in the right position. I think now. Are we pushing this in the correct spot? Hope so. Come on. Now it looks like it's going through. Is it? I think it's not going in completely. Why is it still looking like it's blocked? It's not moving. It's weird. The fan is not moving. It's actually nicely slotted in place, but the last 2 millimeters I can't actually get the screw into the counter nut, which is on the other side. It's not working. Not sure why is this blocked. Just should be pushing it in. And now it actually looks like the slot is actually free, so I can see through it from this end. Can't really see. Is the screws are different length? No, not really. They're all the same length. That was the interesting part. All the screws are the good part actually. The screws are all the same length. They should actually go through. Now it works. Okay, maybe I just had it kind of misaligned. Okay, fine. So let's do some cable management now. The tedious section. The not so funny part. Okay, so I'm trying to wrap everything back into this thingy here. Let's see if I can make this look as nice as it should be. Okay, I guess we're gonna push it down a bit more, so we're gonna get closer here to the fan. Not too much, and then we can start reinserting the cables. Starting with the Hotend cables. I'm trying one at a time, or like at least not more than 2. Otherwise, I believe it's going to be too difficult to get all the cables in at the same time. Probably, and there is a little, yeah, that's what I was kind of afraid of, is that these chunky connectors are going to be visible here, because this this shrink tube is, or the cable wrap sleeve is not big enough. It's not, the diameter isn't big enough so that it is able to really hide those connectors and really like go around. It's a bit too large actually. But how they show this here in the instructions is exactly like that. So this should be fine. Technically, it should be the right way to do it. I fear that our nice cable management clip, if I'm inserting it right here, it might be that it is, it could be just right, just low enough that it's not going to actually hit this section where these chunky connectors are. Hope this is actually true. So let me finish this first. Let me get the three cables in, and then we'll continue with the what is it here? The two blower fans, yeah. Bottom first, then top. Yeah, still kind of difficult to get everything into the sleeve. As I told you, this is the tedious part. Everything else was easy peasy. Okay. Well, it's pretty short actually. There's not much cable from the Revo cables. There's not much left here. But this cable is probably just long enough. This cable here, which is the motor cable, I mean, that didn't change. Okay, so we're starting. We're gonna do the cooling fan cable. Let's try to get it in. Thing is, we need to get this all behind these huge cable plugs. That is really chunky cable plugs. Don't like that. Let's try to get the second one in at the same time. I guess maybe we should probably be able to do this. Two cables at the same time, it's probably possible. And then we also have, finally we have to do the sensor cable, the filament sensor cable, and also the extruder cable. So all these cables need to go in. You'll see in a second. So we're not really done yet. Some more cables going in. I guess that I want to secure this section in the first place. I want to get this mounted with this management clip. Let me just figure out which direction I need to go so I don't break anything. Probably this way. You have to push this over, and then we want to have it like that. So it's like holding the cable in this angle, at an angle. So let's just fix it in place. I guess this is the best, like, so it's not coming off anymore, and it's not any of the cables are going to come out here. Hope I can get this fixed now. It's probably not the easiest thing to do. Can I get the screw in? Yes. So this upper section is now secured. So we can continue getting all of the cables in place, and then we have to also fix it to the extruder here on the side, then get the extruder motor, the sensor cable in. Just gonna continue getting all these like long cables in, and then we're gonna finish with the, I'm gonna disconnect this as well. Hope I can remember where all the cables go in the, in the end. So that we're not connecting something to the wrong port, but hopefully, I mean, you can always check in the Prusa documentation what are the cables, where are they going. It's not the problem. So let's see. So you get some practice, you're getting faster. The good part is now, since this is now fixed, I can pull a little bit, and it's actually easier now to insert the cables while this is fixed on one end. So let's make sure that we are wrapping it correctly. Good. So this is just the tool head cables. Almost 20 to 30, we'll get to bed, need to get good night. Yeah, get some sleep, my friend. Get some sleep. So we are continuing here on the extruder. Just want to make sure that we are still have enough slack with the cable, so we're not basically not creating any kind of stress on the cables. Just giving it enough bending radius. I think this is fine. So you see, we want to fix it here to the side, just here. And we want to give it a good radius, probably just following the path of the PTFE tube. And then we have enough length. We still have enough cable that goes down to the main board. So there's plenty of slack there. Could give it a bit more even. And what's left now is really to fix it up here at the upper end with a zip tie. It's going into the IFS extruder, just fixing the cable there. And then we can, I mean, what we can do right now is just pushing the rest of the cables, the filament sensor and also the motor extruder cable, into the sleeve, so it will be done, so we don't have to think about cables anymore. I'm almost there. Almost done. And this sleeve is packed now. It's really, and it's very limited in terms of how many cables can take. So, but it was the same before, so it's not different actually. Probably at some point, if I ever need to replace this, I'm gonna take a little bit of a bigger one, for a little more diameter. So it's a bit, let's say, especially also with these cable connectors up there, these little plugs here. It's nicer. Finally reaching the end of this. So now we want to make sure that nothing comes out, nothing sticks out here. So we're just gonna push everything in nicely. So it's really going around the cables, not just like that some cables gonna try to come out here. That's a bit tricky. Okay, I guess we're good. For now, we're good. And now it's time to actually find the best position here to fix it, and also that no cable is sticking out here. It's fine, I guess. So job number 1 is done. We can now fix this upper part. So show you how this is done. Here we have the Bondtech extruder. The Bondtech extruder has a filament sensor cable that's coming out right here. We have one zip tie at the upper end, and now we can adjust the cable so it is just long enough. Right, and we have this fixed in place. I'm just gonna want to do the second zip tie just under these two cables, or at least in between the this extruder cable will be on the upper end, and I think the sensor cable will be going in here. So we can do the last zip tie. Where is it going in here? So I think it's good. Just want to make sure that I'm not just pushing the cables too much or getting them in a too much compression. Just holding the thing in place, and now we can, I think it's good in terms of the length. Is it? So let's put the zip ties over here so nothing is blocking. Yeah, we can just go to the very end. That's good. So we definitely don't want to block the path here. So that's why we want to like really compress a bit, and also put zip tie locks really to the side. Nothing is blocking here. That's fine. Okay, this looks fine to me. The tool head is moving to the very end. Yeah, there's a tiny bit of spacing here, but that was probably the case before as well, because this is a bit chunky. Probably it's actually not avoidable, but I guess we're still good, right? We can still move the tool head to the end. Yeah, so for the homing position, I think this is still working. We'll see. And now it's time to connect back all the cables to the main board. The problem is only that I have to do the cables in the right position. So let me see what this was. The cooling. This was. This is the sensor X motor. Like, don't want to mistake any of the cables here. This is the where does it come from? This is the sensor cable. This is the Z, but this is not the cable that we're looking for. So actually, we should be good. This is the temperature cable. Which is the right orientation. This way. Okay, and we want to make sure that in the end we're going to have it mounted here. And the whole, we need enough slack that it can move up and down and it's not creating any issue. So I think it's still long enough. It's just all of the cable length should be fine if we make it fixed like that. We have enough slack, get the tool head up and down, and the Z axis is going to move freely and there's not going to be any stress. I guess so. Good. Let's connect the cables back. This is the where's my motor cable actually? Where is it going? This is still connected. We have one more. There is the this is the cable for the heater. Let's also connect that. Good question from Xylon. Any firmware adjustments or plug and play? We'll figure this out in a second. We'll figure this out. So this is pretty long actually. I'm not sure. We need to kind of figure out how we can have this long cable in the housing without creating any issues. Now the big question is which of these cables are going where. So we have 1, 2, 3 plugs here. Just want to make sure that I'm not putting anything in the wrong slot. Let me double check the Prusa manual one more time so I'm not mistaking any of the cable plugs. So we are not... Okay, so there is Hotend fan, print fan. Okay, Hotend fan was... The Hotend fan is this one. Where's the print fan? Is the blue-red. Okay, so the Hotend fan is this cable. It's the first plug actually in the corner. Print fan is this cable. And then finally, we have the sensor, the probe plug. Okay, and that's the black one. Good. I guess we got every cable in its position where it should be. Let's do a little dry run. And then we also want to look up in the instructions, do we have to do any firmware modifications, any settings that we need to modify? The only setting that is potentially to be changed is maybe the sensor type. So let's figure this out. Where was my instructions? Here. So we're going to, we are closing this in a second. We did this here, it's done. Yeah, so the cable management arm. We did check that we have enough cable length. We fixed this to the extruder. We also fixed the blower fan. Final calibration. Okay, so we are going to do pit tuning. Okay, so final calibration is probably just a basic calibration of all the sensors, motors, fans, which is the usual procedure. There's nothing changed there. Pit tuning makes sense to me that we're doing the pit tuning because we want to... Yeah, we have a new Hotend, but besides that, there seems to be no changes. That's great. That's actually awesome. So we don't have to do a lot of stuff here. That's why I think I'm gonna just keep this open for now. Don't close the, I'm not gonna close this electronics case. I'm just gonna try everything before we are closing, and then let's do a little self-test with the printer. Okay, so what does the temperature sensor say so far? 23 degrees. We're going to, I think it's hardware. Is it hardware or system? Let me see. It's probably or was it a calibration menu? I'm not sure. Control, calibration and test. Okay, I guess we're just doing all of the tests. Let's do the fan test. So both fans are running. That's great. So these cables are connected correctly, I guess. Thinking about this cable. Let's hope that is not getting anywhere. Fan test in progress. Please wait. Okay, question. Continue. Yeah, we're gonna continue running calibration tests. We're gonna check all the axes. Seems to be working. So the movement is working. Just looking good. So now we can figure out how much cable we want because it's coming down and how we want to orient the cable actually. So it's bending in the right direction away from the print bed. Well, it looks good. Looks good so far. Guess we can bring it back into the final position here where we have the cover on. Is it working? Yeah. Okay, I think this is plenty of space to move, so it should be good. Just want to secure this. Cable is working, so now we're doing a heater testing. Is the heater working? So he's heating up the hot end. Temperature is going up 100 degrees. The heat bed is also heating up to 100 degrees. Wow, that's actually interesting that it's trying to heat the bed up to 100 degrees. Never saw that. And then 138, 140 for the nozzle. I'm wondering why is it... So the heater for, like the Hotend heater test is actually complete, it's done. To calibrate with currently loaded filament, press next. To load filament, press load. Okay, so let's get our PLA loaded so we can see if the extrusion is working. My friends, we're getting there. Getting ready. So I guess we're not far from printing. And it was actually surprisingly easy to do. Like, except the cable management, which I did not like that much, it was fairly easy to swap out the Hotend. Oh, we want to cut the filament tip. Good. Let's try this. Can we get filament in? Or is it? Ah, so load the filament. PLA, okay. Yes. Let's do it. Now comes the moment of truth, if we are actually extruding filament. If the nozzle system is working, but I guess it's working. Basically I have no doubts that this is going to work, since the tests have been done. Okay, let's see, pushing through. And my friends, we have filament coming out of the nozzle. Strange part actually is, and it's maybe the wrong, yes, the color is correct. My question here is, why is the, maybe maybe I actually have the cables confused. No. I'm wondering why the fan. Guess I have cable fan. I have the fans swapped. That's my guess here. I think I have the fans swapped. So the fan for the Hotend fan is actually the cable, to be honest. This is actually the wrong cable. This is probably, yeah, that sounds better. So that's what I was thinking. The side blower, which is cooling down the Hotend, didn't turn, but actually what was running was this fan at the back. So the actual part cooling fan was blowing, and so I swapped the cables, put them in the wrong connectors, the wrong slots, but now it should be good. I did a reset of the offset values because I think that the offset is going to be different. And now we're doing a recalibration of the Z offset, so we make sure that we actually have the right nozzle distance. So we can start printing, getting the fast. I think the first thing I want to do is actually go straight to the flow rate test, and then we're gonna swap to the high flow nozzle to figure out what kind of flow rate we can get from that. So we're gonna see the difference there. Interesting. I think that the sensor, it needs to be adjusted, to be honest. I think the sensor is a little bit too low, or not, I mean, it's too high up, if you ask me. I guess that we need to bring the sensor down 1 or 2 millimeters, actually. Maybe that's what we are losing here. Let me just stop it right there. Because it's very, very close to the print bed. The nozzle is maybe not touching, but it's super close. So for my taste, it's too close. So I guess I want to bring down the sensor by just a tiny bit. Maybe 1 millimeter or something there is. Hopefully I can just do it now by screwing it down. I don't want to put too much stress on this cable. Not sure if I can just skip the, yeah, I can just skip the threads. Don't want to push too much, I just want to turn it too much. So I brought it down a good bit. So let's fix it. It was, for my taste, was too low. Was actually thinking that I had the impression that it was already touching the nozzle was already touching the print bed. Could be wrong, but yeah, this is an adjustment that was what you were, like what we were asking for, right? So you were, I wasn't sure. Let's do the auto home again. So we're probably down by 1.5, 2 millimeters something. Yeah, it's now stopping. I mean, we shouldn't bring it down that much. Let me see how low I can go with the sensor now. Well, there's a bit, and we have still some room here. Let me go to 0. Not sure. I'm not sure how much difference there should be. Let me just do the calibration one more time just to figure out how much space there's going to be in the end. So let's do first layer calibration. Next. No. I don't want to use the original values. I mean, the nozzle should be a little bit higher now when we start with the calibration. But the sensor is also quite close to the bed, so I'm not sure how much of a difference there should be in the end. Probably it's very little. We're gonna figure this out. Don't want to come too close with the sensor. Hope it will work. Yeah, let's see when it's triggering. Yeah, sensor shouldn't hit the bed, but the nozzle, I mean, my main concern is the nozzle shouldn't hit the bed. Now, I think the sensor is triggering actually quite early. So we are maybe a little bit too low with the sensor now. We can bring it up by, I can bring it up by 1 millimeter maybe, or 0.5 millimeter. Let's see. Let's bring the sensor up again. It was probably a little bit too much. So let's see. Can just push it back by, can I get it? Yeah, so that's probably enough. I mean, that's the part with the firmware of all of the Prusas actually. They're booting up like in 5 seconds, right? That's really super fast. So I just want to get this up. Just want to close the electronics case. I can't really look at this. Honestly, I want to get it back into the good into the clean state. So it's really looking like it should be looking. I think also the cables should be swapped. Is it the correct position here? I think I need to swap them. So that is actually going left. This is how it should be. Yeah. I'm not so sure. Yeah, I think this is the way. So this one is on the right, and the main cable is on the left. So let's get this fixed. Just want to have the electronics case closed, so everything is nicely in place, not moving anywhere. So let's try if the cable is still long enough now, moving up to the very top position. Is it? Yeah. I guess this is fine. Okay, so let's do the calibration first layer one more time. And let's see. Heating up. So far everything works fine. The only thing is really just the sensor distance that is worrying me. But this should be the last thing to correct, and then we do the pitch tuning for the new Hotend. So I should be starting in a second now. So the nozzle isn't touching the bed. There is still a little bit of space. It's not much, maybe I don't know, millimeter or something. Yeah. It's okay. We're not touching the bed. It's very close. But there's like, you can like, if you're really looking close, it's not really touching. Okay, so let's do the calibration. I think this is good. Temperature is coming up, 215 degrees. Let's get a little bit lower. And here we have the brand new Revo Hotend finally working. So we're doing a first calibration print now to figure out the right distance. The first layer is coming down. Actually, we don't want that here. So we're still too high. Going lower. So I want to push that first layer down so it is nothing is actually moving anymore. So if we scratch this, it should not detach that easy anymore. It's still easy to get it off. So we want to squeeze the first layer a tiny bit, right? And you can do this with the fingernail, just testing whether it's sticking. It's also like still very high, let's say. So I tend to squeeze the first layer a bit. So what I prefer to do, so I really get some stickiness there. That might lead to a kind of a little first layer protruding out, especially if you have something very edgy that you're printing. You will see this first layer is a little bit squeezed, but for better adhesion, I think this is something that is a bit better. Like if you have a little bit of a squeeze, it's not really the worst thing. Actually looks fairly good now. Let's see the little square that comes out here. That's coming out nicely. Okay, so get everything off. Actually, what's most interesting is really the last little square. If the layers are still separated, and you can see the last the square that it printed, the layers are still coming apart. So that means we could even push it a bit more, so they actually get connected better. I'll just repeat this. Using the same offset now, so we don't have to go back and finding that perfect value again, starting with this the very value that we just used. And we're just going to do it again. Maybe I'm going to push down the nozzle a tiny bit more, maybe 0.1 or something. How late is it? Almost 11. 10 after 11 actually. Not almost 11, it's actually after 11. Has anyone tried PCDG, and if so, is it worth trying? Andrew, we did try PCDG already. I had it, I printed actually this hammer with PCDG. So this is a full PCDG hammer, and I also tested it. It's actually, like you see, I nailed in stuff and it's not broken. It's really super sturdy. It can take a hit, as you see. Super stable material, much harder than PETG, and it's still easy to print. So it's I would say worth trying if you have something that needs to be very rigid, that shouldn't be elastic in a way that PETG might be, and has a little bit of temperature resistance. I think it's not that great. Depends a little bit on the brand. The brands that I'm using here is 3D Jake. The printing temperature of that material is 250 degrees to 270 degrees, and the bed temperature is 90 to 110 degrees Celsius. So I would say this is a high temperature material. So bed temperature 90 to 110 requires probably an enclosure. Might be that you're getting away without it on a printer like this, but it could be. It could actually be working. Yeah, I'm not sure. Didn't try this on a printer without an enclosure actually. So we could push down a bit more actually. Here it's still not really squishing that much. Now it's better. Let's see. I don't want to run the nozzle into the surface here, but I also want good adhesion. So for me, it looks like we have a pretty good value now here with minus 4.4. It's a bit more, like it's 0.5. Is it? No, 0.05 lower than before, so not that much. So the first layer test has finished. Let's see if those first layers still come apart. At least not as much as before. It's a little bit harder to separate them, but yeah, I think this is good. We could push it even more down. I guess it's possible. It's not going to be an issue. But it's also pretty stable now. It's pretty good connected. Again, you can force it apart, but it's not super bad. Okay, so we don't want to repeat this. We want to go for an extrusion speed or like a flow rate test now. That is going to be the next test. So let's go to maybe do the pit tuning now. This is one thing left that was actually on the list. So let's do that first while we are looking for the calibration test. So is the pit tuning also in the control menu? Probably temperature, no. Let's see. It's not part of the calibration, seems. So maybe... I'm not sure. So it is probably in this advanced menu. So let's see, settings. Here we go. Not sure if the pitch tuning is in the advanced. Seems not. No, I don't want to save any changes. System. Hardware. Printhead? No. Let me see. Where's this menu? Somewhere hidden. It's probably Prusa recommends not to pit tune the menu. So they don't recommend actually to do this, or Prusa is not recommending this. Okay, so there's actually a fixed pit tuning value in the EEPROM, and we cannot save that value. Well, this is weird. Interesting. That's at least what E3D has in their instructions, that you cannot change that value. That's interesting. Okay, so anyways, let's go further and let's hit the next point on our list. We're gonna go for Orca Slicer. And within Orca Slicer, we're gonna do the max flow rate test with this specific material, which is still the ESON EPLA high flow, high speed material. And we want to figure out what's the maximum high flow rate. We did have a 17.5 cubic millimeters in the last one, in the last test. Why is Orca Slicer? Is there a new version? Okay, maybe let's just do that. Yes. So I'm just getting the latest version installed. Let me know what you're thinking so far about this printer. I'm thinking that we should be good for testing different nozzles now. From my point of view, there's nothing else to do here in terms of modifications. So first test that we're gonna do is the flow rate. I'm not expecting any huge differences, to be honest, between the original Hotend and the standard 0.4 nozzle here from E3D. But I could also be wrong. That's why we're going to run the test. And Prusa has a setting in their menu, which is also which will determine if there is a high flow nozzle installed or not. And also like a hardened steel nozzle. So we want to definitely get the settings right. Actually, I think this is not a hardened steel nozzle. I'm not sure what the differences are in terms of settings, but maybe you want to swap back to the printhead. So nozzle diameter is still 0.4. Nozzle hardened is not the case. This is a standard nozzle. Nozzle high flow. So we have these settings. But I'm going back to standard. No hardened steel. No high flow at the moment. Fine. So Orca Slicer, where are you? Is it starting now? Oh, there it is. On the wrong screen. So let's get it going. We have the Prusa Mini 0.4 nozzle. We have what kind of filament are we using? With generic PLA, 3D check, PETG to Eco PLA, Prusa Man PLA, generic PLA. So let's create a new setting here, a new filament, which is basically ESUN high flow PLA, or even as correctly called ePLA HF Y at system. I don't think this is a user preset, and we're gonna keep everything as it is for now because we're gonna just use it as a point to save our new values. So we are doing a max flow rate. I'm gonna do a max flow rate test. We're starting, I guess we're starting at, I don't know, maybe let's start at 15, because I mean, that should be something that is achievable. And we're trying to go, I mean, our limit was 17, so maybe just start with 10. But I guess this is too low probably. Let's start with 12 cubic millimeter per second. Let's go from 12 to, I don't know, 25. Probably gonna hit the limit earlier. We just have to remember where we are. Oh, let's go with 15 actually. I guess 15 should be good, because we ended up using 17.5 in our last test. So we just don't want to print too much material before we figure the limit. Doesn't make sense to go like start with 10, because it's gonna not change anything between 10 and 14. There's probably not gonna be any difference, and even 15. That's my expectation at least. So let's try 15 to 25, and I'm probably gonna hit the limit at the very same spot, maybe. Just a guess. Same height probably is gonna be our limit with this material and this nozzle. Before we are going to swap out the nozzle for the high flow. So let's get going. I want to actually put this on the USB stick. Okay. Can we just export it? Yeah, let's put it on a USB drive. Okay, I checked. And we're heading over to the printer. And it's already asking for a print start. Just hit print. $13mm per, yeah, I mean, for PLA, standard PLA, this is, but for the high flow PLA, I guess we can go higher. And we have a different extruder, right? We have a Bondtech, we have a different throat. There's a few modifications on this printer actually, so I guess that we can push it a bit more. If we even were able to print at 17.5 with the original stock Hotend with this filament, why should it be so much lower? That would be strange. That would be disappointing actually. But let's see what we get out of this. Some people also like mentioned about the Revo high flow, that it's actually not that great, but yeah, I'm still curious how much we can push that in terms of the limits. Let's see. I also like to adjust, so I think it's a bit unfortunate that the first purge line is actually too much to the front. It's really, the filament is actually hanging down, or it's like dropping down from here. So I guess, I'm not sure why this happens actually. Maybe the nozzle is a little bit further to the front now. This could be the reason actually. So maybe I don't know, 0.5 millimeters or a millimeter to the front, which then causes the filament to drop over the border here. Like it's just dropping down there. It's not really on the print bed. That's why. No, it's maybe just there. But it's okay. I mean, we can just get it off now and see what happens now. There you go. We're starting with 15 cubic millimeter per second extrusion in the first layer. Or probably not that. I mean, this is the very first layer. The first layer is probably just a bit slower because it is creating the brim, and that probably is lower print. So we're just not going to see the actual print speed before layer 2 comes. Nozzle distance looks good. Probably about 2 millimeters, I would say. So enough space there. Let's see. We're still printing very slow. It's still printing the first layer, the brim. So this doesn't come off the bed. But then it's gonna accelerate very soon. Just doing the first few turns here. My friends, what do you think about the latest Bamboo Lab release? Was anyone watching that? Was anyone like going onto the webpage every single day, looking out for the announcements, the secret features that this printer might have? And then in the end, personally, I was a little bit, I'm not sure. On first I was surprised a bit, but I was also disappointed because I was not expecting them to try to get everything that you can get into a printer into this device, like and making especially the laser engraving a part of a printer. Think about that. If you are actually laser engraving materials like, I don't know, wood or like anything that is like creating dust, fumes, toxic stuff, it's not only about having this in the machine and it's convenient because it's in the machine, but it's also creating this kind of dirt in your machine, right? So actually things that are going down inside of the printer, on your mechanics, on your motors. And at some point you need to clean this, and then you're also like, if you have ever had a laser engraving machine, and I had two, and now I have a new one that I still have to test, but it has all of the extrusion or it has this ventilation system, right, which is absolutely necessary. You need that, because otherwise it's going to be a total disaster if you're running this in your workshop. So without any like proper ventilation and like getting all of the gases that will be happening in the laser engraving area, getting that extruded out through a filter system and stuff. And I mean, the printer might have some filters, but these filters are not big enough in the first place, and the filtration system is probably gonna just, I mean, it's going to destroy the filter in a couple of minutes. This filter is going to be saturated, honestly, if you're doing something like balsa wood or whatever, plywood cutting. It's going to be terrible. It's a terrible idea. And if you read the reviews, most people won't even consider this, getting the printer with the laser. And I have a story that pretty much fits in here. Like, we had a kitchen like back in the house of my parents. It's already like 10 years ago, but the thing is, they had a microwave that was integrated into the actual normal oven, right? So they had a normal like baking oven, the kitchen oven, which where you would bake your bread or whatever, bake the cake, and that oven had an integrated microwave. Pretty convenient idea. I mean, this was back in the days when they bought it. It was kind of a nice invention, because you didn't need an extra microwave in your kitchen if you didn't have that much space. Actually, a nice idea. But like 10 years later, the microwave wasn't working anymore. The oven was still working, but the microwave stopped working. And then we called the Siemens customer service and asked for like the repair, like an offer for repairing this. Like, how much would it cost? And they offered us to repair the microwave for 500 euros. Guess what happened? My parents got a separate microwave and put it in their kitchen. So that's why I think it's sometimes better to have separated devices, because if something breaks down and you need to replace electronics, or like even if the electronics for the laser engraving are somehow combined with the electronics, at some point it's going to be integrated, right? So there's going to be a main board, a main board, and probably some other boards. But if some of this has to be replaced, it's going to be a lot of work, and also probably potentially expensive. And maybe you need to swap out parts that you actually are not even, like, normally you wouldn't swap out, because it's also parts that are controlling other parts of the printer. I'm not sure how they designed this in a way that they maybe have separate main boards for everything, and then you can swap out electronics for the laser engraving separately. I'm not sure if that is actually the case. And that's why I think like having a separate machine is not only about the cleaning and all of these side effects, but it's also about, if the machine doesn't work anymore for some reason, it is maybe cheaper just to get a new laser, or if you want a bigger laser machine. I mean, honestly, that size of the laser machine in the printer, if you think about what other lasers are now in terms of sizing, the usual size that you can get now for very cheap is 40 by 50 centimeters. So much bigger area. And if you have something that is actually bigger than the printer, like let's say you have a sheet of plywood that is, I don't know, 50 centimeters long, and you can just put it under your laser engraving machine, because the laser engraving machine is just a frame essentially that you put on the table. Like most of the cheaper models, at least. And even if you have an enclosure, a lot of these have a slot where you can slide in stuff from the side, right? You can slide in longer parts, put it under the laser, and then slide them out to the other end, right? Even the big ones have that. And so you can actually put much larger pieces under the laser that are even bigger than the machine itself. So I'm not sure if is this actually useful to have a 30 centimeter laser engraving area? Probably not. So we are already printing now much faster, and we wanna take a look that we're not missing the sections where it's gonna fail. So it's still good. And how you can recognize when it's failing is actually, first of all, the color change. Also the shininess of the material is going to change a bit before the actual failure happens. And then in the layer where the failure happens, you will see that there is just gaps. So it's just gonna not extrude anymore. So there's gonna be little gaps, and the extruder is potentially also clicking. So once the extruder starts clicking and skipping, we know we already have passed the point where it's failing, and we probably want to go down by 0.5 to 1 millimeter to be safe. That's what we did last time, right? We were like hitting this point where the extruder was making the clicking noises, and then we were like, I was looking at the height, and then going down by, I think I went down a millimeter to be in a safe area, and it still was 17.5 cubic millimeters, and that's pretty good. So now let's see how far we can get with this one. We're already at 4 millimeters. And how to calculate this is actually, we're going, you take the initial height, which is 15, and then you look at the height where you think it's still safe to print, or where the print was still like looking great. You basically just add that to the original value. So let's say we are getting 5 more millimeters where we still have a nice result. We're adding that to 15, we have 20 millimeters or something, and then we are going to multiply that with the factor, right? So the factor is, or the additional value, we're going to multiply the additional height with 0.5. So it means like if with every millimeter, we're changing the extrusion by 0.5 cubic millimeters per second. So we're starting at 15, we're adding, let's say we're adding 10 millimeters, and we are multiplying that by 0.5, we're adding 5 cubic millimeters, right, to the original 15. So that's why we need to check how many millimeters we are still printing in good quality, and then we're going to calculate how much that is in terms of cubic millimeters. So it's just a multiplication by 0.5. Probably have a detachment here. At the back, it's not sticking. So that means we probably have to repeat the test. Yeah. One reason could be that we are still not, and we have to stop this, it's not working. So the thing is, detaching is like a very thin part. It's very hard to make it stick to the print bed. The reason can be that we're still not pushing enough. And last time I was just putting some adhesive, but you see all these layers are still kind of coming apart. So we probably want to push down a bit more. So that's part of that's the initial tuning. I think we want to push down the nozzle even further, just to have a little bit more adhesion. And we can also use the spray, which we did last time, where I put some adhesive on. That did a little bit of a difference and made it a bit more sticky. But just looking at the layers, how easy they come apart, I think it's also still not enough push. Yeah, printing and laser at the same time, it's good. It's a good point, right? If you are doing something with the laser machine and it's gonna take a while and you want to print, and I mean, I don't see why we would pay so much. And also the price, think about it. The machine is $2,200 just for the printer with the AMS. Honestly, probably no one's gonna buy the solo printer. And the laser is another, was it 500? And then the more expensive laser is another, was it 800 euros? Or even almost 1,000 euros more than the 10 watt. So the 40 watt laser is, I think the difference was around about 800 to 1,000 euros more. So it's like 3,700-ish for the whole thing, with all the bells and whistles, as you say. So I'm not sure what is the target audience for this. Like, who is going to buy this? Right? You must be a very, very enthusiastic person to get it for that price. And then you should have a good use case, right? If you don't have a good reason to run this, you should probably not spend that much money on this kind of combo. You should probably just stick with a good 3D printer that is, I would say, at a good size. I mean, you can get so many printers nowadays that have a good build volume, like 300 millimeters. Yeah, that's the H2D. Like the H2D, I mean, I've seen it, and I'm really wondering, who is it for? Really, I was asking this question to myself, like, who is going to buy this? It's really a question I can't answer for myself. It's really difficult to answer. I don't see myself buying and paying money for this device anytime soon, unless I have a very, very compelling use case that really requires this. But for now, I would say I don't have it. I don't see why. I'm just checking if it's just here at the corner in this area here. It's not sticking that well. Not sure why. We're still too far away from the print bed in this area. Still too far. Here in the middle it's a bit better, but here it's good. On this side it's really terrible. It's not like, probably we need to clean it. Just 1 second. Whew. You would love to have one, but at the same time I had cars cheaper than that. Okay. Well, that's a good point. There could be cars that are cheaper than these H2D. I'm wondering if it's going to stick now. If not, we probably have to use the adhesive spray on top. I'm not sure why. Yeah, it's probably fine now, but I went down by another point. 0.05 something millimeters. And here in this, like on the left side, we're pushing, actually like squeezing quite a lot already. And on the right hand side, it's not the case. So probably we need to, maybe also need to repeat the leveling test, or the bed leveling in general, like the point calibration. I'm not sure. Yeah, so in any moment it's going to go faster. But I like the look, and like it's the whole upgrade looks so clean. It's very so well integrated, so it's not really bigger, it's not heavier. And the nozzle swapping is going to be so easy. That's why I really like that. So let's see how these kind of the first layers are going to stick this time. Yeah, so we are just too poor to buy the H2D, right? I don't have the budget to buy that printer. As you say, tactical tug. I would love to have one, but it's completely out of the budget for me. So now this is the print speed that we're looking at, 15 cubic millimeters per second is the extrusion rate here in the very first layer, and then we're going up. The upper limit that we set is 25, just to remember that. 15 to 25 is what we're going for. Yeah, Snapmaker is... I never understood that brand, to be honest. I think it's kind of a mystery. Wasn't that this super crazy Kickstarter? Like the highest funded 3D printer Kickstarter ever, and then like everyone was super hyping this printer, and I never saw this printer in anyone's... Like, never saw that anywhere with anyone that I know that who has 3D printers. Never talking about Snapmaker, never had any. Here in Norway, the H2D with a 40 watt laser goes for just under 4,200 euro. I mean, this is crazy, honestly. I'm rather thinking about building a Voron printer, right? And for, let me think, for, I think around about 1,300 euros, I can get a full Voron 350, also the Voron 2.4 biggest size, to 350 millimeter, with the latest revision, so revision D, with the latest mainboard. What was it? I mean, let's check it out. I mean, let's check out the pricing. Like I was just looking at that the other day. I was thinking about like how crazy can it be? But the Voron, like let's switch to English. Here we go. So Voron, and I would only go for the LDO motors version, right? Because that is the best of the best hardware. And think about it. This is the Voron 2.4 350 Rev D kit, 1,500 euros. But yeah, Dragon High, I mean, FormBot is a bit cheaper, I guess. That's right. With this one, you get couple of interesting things. So you have, I think, revision, you have already the Leviathan mainboard, right? I think none of the other kits, the cheaper kits, don't have the Leviathan. There's a few more upgrades here which are different. There's also the Revo Hotend. Let me see, the all 3D Revo Voron. So it's like, I'd say the LDO kit is of course it's more expensive, but it's there is this premium hardware in there. And the cheaper ones, I mean, you can go for, like, let's say 1,000 euros, and then, but at some point you want to upgrade, you want to invest in a new Hotend, you want to invest in a better mainboard. I mean, if you want a latest and greatest, you're spending 500 euros more at some point anyways. Right? It's unavoidable that you're going to spend the difference in some way for upgrades. So why not go all in in the first place? I mean, it's tempting, right? And if you think about it, you have a fully customizable 3D printer. It's also not cheap, of course, but it's also large. It's even larger in terms of the build volume than the Bamboo Lab. It has a Revo Hotend, so you can swap out the nozzles. It has, you can do a little bit of here and there, a couple of modifications. Also, the first layer calibration is mostly perfect, I would say, for this printer. And there is even better sensors and like this super fast scanning and stuff, of course. But it can't, like, if this printer is perfectly tuned, it's probably one of the best printers. It's just, the question is really, why would you go for something else? And you need to have a very good reason to go for something else. If you are not into tinkering with the 3D printer, of course. But I mean, if you think about it, it has open source software, so there's not going to be any cloud. You are not bound to anyone's permission to print or permission to use XYZ filament or whatever upgrade you want to do, you can do. And if you don't want to upgrade this printer, if you just want to stay with what it is, you can also be happy, because it's probably going to be working like a workhorse. And if something breaks, you can just fix it, right? It's like there's no spare parts that you need to buy. It's just printed parts. So, and I see we still have this problem with the detachment, and I think the only way to solve it is actually the spray. As we did last time, we used the spray. Okay, it's unfortunate. I didn't want to spend so much time on this problem, but maybe it's unavoidable. So let's just do it one more time, one last try. Let's get this off. I mean, this is way too easy, to be honest. It's really way too easy. But I'm gonna be lazy, and I'm just gonna use my easy adhesive spray here on the surface. I'm gonna spray that on. Just a quick spray, and I guess the problem is gone. Because I have no intention to investigate further. That's why sometimes, I mean, if you're using adhesive spray, it's the easiest way to go. Last time it worked just perfectly, just because of this very reason, right? Because sometimes, and it's also maybe the filament, because this high flow filament is sticking a little bit different than normal PLA and other materials. Normal PLA is actually sticking a bit better, and the high flow PLA is a little bit more demanding. And then also this printer surface is also not, I mean, it's not that sticky. It's fine, but it's not perfect. And there is better versions of that build plate now. And yeah, why bother even thinking about it too much, right? Just use the spray, a little bit of the adhesive spray, and it's perfect. It's like, I'm not thinking too much about it, to be honest. So the Voron kit, yeah. I guess at some point, maybe if I find the time, I might be leaning into building that. But at the moment, I'm more looking towards actually printing more stuff and doing a couple of interesting print projects versus building a new printer. Actually, I'm currently giving away and selling most of my printers that I have been building. So all of the custom printers that I built in the past, most of them I'm going to probably give away to friends. People who are interested here, like there's so many like people are in the local area which are happy to come by and fetch the printer, because honestly, most of the like older 3D printers that I have super customized, I don't want to spend more money and time into them or fixing them or upgrading. I'd rather reduce the whole fleet to a couple of like very selected printers, for example, like the Z100 up there and maybe the Voron Zero, but really not that much more, right? Because at some point you're not having any time for anything. But you don't have the time. It's simply this as simple. Actually want to work on the playlist a bit. Let's see. Just want to add a few more tracks to the playlist so that it's when it's repeating, it's like maybe at least an hour or so, that like, it's not repeating that early. Now, how's it going for you? It's pretty late. So how is it going for everyone? I'm interested. Are you still awake? Or are you just going to sleep? We hit peak stream already. We're down to 10 on Twitch and 6 on YouTube. So I'm curious what everyone is doing. For me, the night is... Oh, it's pretty late, like it's already midnight. Barely awake, Salion. Okay. Yeah, I think for today we're very soon coming to an end. I think it would take us probably another hour to finish the tests. So I'm trying to get this down now so that we are getting the first test at least done. We're figuring out how good the Revo Hotend is with a standard nozzle. And I will keep you posted throughout the week on the other nozzle types, maybe doing a few more tests. Watching 3D Army making a shelf. Okay. That's fun. I hope you enjoyed this so far. I'm personally pretty happy with the result. I think I'm gonna like this printer even more now. And it was really a workhorse. Throughout all of the years, it was printing a lot and I wasn't thinking about it that much. I was neglecting the maintenance quite a bit. I didn't do any maintenance, to be honest. And now it got its, like, probably since 3 years or something, it got its first kind of proper maintenance and greasing and cleaning. And but in all of the years that I used this printer, I was mainly printing smaller things, but PETG, for example, it's just working and it's just doing the job. It's like doing parts and parts and parts and parts and parts. I was printing probably 100 parts in one session in I think 2 weeks, repeatedly, with 0 problems. There was 0.0 issues with this printer ever, except in the beginning when I was like realizing, okay, we need a more powerful extruder. But after that, it's just working, and that's. I mean, in the end, with everything that's happened in the meanwhile, with all the printers that came out to the market, reliability is probably the thing that you start carrying if once you need it. Once you have something that you really need to get done, you start caring a lot about reliability, and this printer doesn't disappoint. That's the reality. Other printers are also good, don't get me wrong. Clicky wheel, yeah, clicky wheel. But I mean, I installed this the Wi-Fi module last week. I think I can now run this printer from the app 90% of the time. So we're gonna take a look at the Prusa Easy Print in a separate video. If you don't know about it yet, it's a new software. I would say it's an upgrade of the original Prusa Connect, and it can slice from the mobile app. So basically, with the Prusa Connect app, you can print G-code files that have been sliced for the printer from printables. So if there is a G-code file for your Prusa printer on printables, you can already print that from the Prusa Connect app. But if you have any file that has no pre-sliced G-code for the printer, Easy Print will be like, would make it super easy for you to just like put the part on the build plate in the web browser. So you don't have to install anything essentially, and then you could start printing, right? You could just slice it, print it through Prusa Connect. So Prusa Connect is still going to be the back end, if you will, for printing, controlling your printer, but Easy Print is going to be the web-based slicer program. And I'm currently part of the tester group, so I'm gonna have 2 invitation codes. Like in the next, very soon I'm gonna probably next live stream. I'm gonna give away the 2 the codes, but we're gonna take a look first at the software. I'm gonna show it, and then we're gonna give away those codes. Not today. So I'm hoping for the best that we're not gonna detach. This printer is hopefully going to stick this time. Okay, I'm curious. Did the adhesive spray solve our issues? I hope so. For now it looks good, but I think the detachment started a little bit later. So once we are at 6 millimeters, so now we are like 4.2. Once we have reached 6 millimeters, we will be that's 6 times 0.5, that's 3, and 3 plus 15 is 18. So if we are still printing at 6 millimeters height and it's still looking great, we are already faster than last time. So we already have a higher flow rate limit. So let's see where this ends. So again, how we calculate this, we take the height where we are, where the print is still looking clean. We multiply that by 0.5, so 6 means we have a value of 3 cubic millimeters, and then we add that to the starting value, which is 15 cubic millimeters per second. That gives us the actual value that we're printing at. So it's already 6 millimeters and it's still looking good. And we're even going faster. It's getting higher and higher and still looking great. I mean, technically the filament has now, we have the higher power heater core, which should keep the temperature at a more constant value. Even if printing faster, the temperature shouldn't drop. And the melting zone is also bigger. So these are all factors that influence how fast you can go, and even with the standard nozzle. So we are now at almost 8 millimeters. That means we have 4 plus 15, or almost 19 cubic millimeters. So still good. There's still no problems here. I'm really curious how far we can go, right? The print is going to end at 25 millimeters. 25 cubic millimeters per second. That means at 10 millimeters it's going to end. No, 20, sorry, it's 20 millimeters. Okay, so once we reach 10 millimeters, we have 5 cubic millimeters more than the starting value. That's going to be 20. So 15 was the starting value. We add 5 more, which we are going to reach now. Just in a second. Now we're going to reach 20 cubic millimeters per second. It's still going without issues, and the detachment is gone, so the spray absolutely did help. And we're still increasing the speed. It's still going faster now. So I'm really curious when this is going to be ending the test. Once we get the first real issues. I think this moment could come anytime now. Especially here in the corners, I see that the cooling isn't working anymore that well. So like probably the cooling fan needs to be blowing actually a little bit more. It's not, but let's wait. And I didn't hear any clicking noises from the extruder yet. We're at like 12 millimeters and we're still going. I think now I can see some minor issues coming. So it's probably gonna happen now. It's very difficult to tell, especially from the distance. It's difficult to see this. Still pushing filament, it's still good. Still no clicking noises. Last time it was really audible from the extruder that it wasn't able to push the filament faster. So let's see. We are at like 13.6 millimeters. (14 millimeters). Besides the fact that the cooling is probably not enough, it's a little bit, it's like bending in the corners, but it's still like the extrusion is still working fine. But let's see. I'm not sure how far this can go, but it's probably just, it's gonna end very soon. It's my guess. 15 millimeters. Okay, so now extruder is clicking. It's slipping, so at 16 millimeters the extruder is slipping. So I would say that was very audible, at least for me. Well, it's not happening now. I'm probably gonna hear it soon. It's slipping again. It's grinding a bit. So it's now very clear. So 16 was, we're gonna stop it here because it does make sense. Like once the extruder starts grinding, it's over. So the grinding started at 16 millimeters of height. Now, if you want to calculate what that means, again, we're gonna go back to the calculation, how it works. So still nothing is visible, like you don't see an issue there yet, but it's gonna, like at some point once the clicking and the grinding starts getting worse, there's gonna be gaps in the print, right? It's gonna really look terrible. So 16, and personally I would say to be a little bit safe, I would deduct 0.5 millimeter. Yeah, so 15.5. 15.5, I would say even 15 is a good result. Like 15, if we just take that value and say we want to be super safe, we're going to go for 15 or 15.5. If we calculate that and say we have 15.5 times 0.5, that's the factor. So that's 7.75 cubic millimeters plus the starting value of 15. We have 22.75. 22.75 cubic millimeters was the standard nozzle. So let's just remember that. Okay, so I'm gonna put this value in the slicer. So 22.75 is. We could be a little bit more conservative and say maybe not 22. Like maybe we're gonna go for 15 times 0.5 plus 15, like 22, right? 22.5. It's still good, still a good value. So whatever, like 22.5, 22.75, it's not a huge difference. In the slicer, like how do we save this? We can probably save this and say ESON EPLA HF flow rate, I think is here. Wait a minute, filament, I think, was it down here? Max volumetric speed. So before we save that, just one more thing, we wanna reset the project settings because that's gonna be messing up otherwise our default. So we're gonna go into the filament, we're gonna save the max volumetric speed and say 22.75. Let's go with a higher value. Let's save it as ESON EPLA HF Revo, right? So Revo standard, right? Say Revo standard. I want to pick a name that I can remember this. Now the thing is, you need to save. That's the thing with flow rate settings. You have to save it for the filament, right? Because every single filament is going to have a different maximum flow rate. This filament with this nozzle has this flow rate. If you swap out any of the parameters, like you're swapping out the nozzle for another nozzle, it's going to be a different flow rate. If you're swapping out the filament for another filament, it's going to be a different flow rate. And your maximum print speed will be a result of that. And that's why you need to repeat this test. Essentially, if you're like realistically, you need to repeat this test for every single different filament type and brand. If you want to be super safe, you probably want to repeat it also for different colors of the same filament brand and type, but that's probably a bit over the top. I'd say for every single brand and filament type, you should do the max flow rate test if you want to push your printer to the limits. It's unavoidable. So we have saved that for ESON EPLA HF with the Revo standard Hotend. I could even say with the Revo 0.4, because technically with the 0.6 millimeter nozzle, it's probably a different value, right? So, right, if you want to be super correct, it's probably different. Okay, so now before we can swap the nozzle, we should have the printer cooling down, so I can safely touch the nozzle. Let's see how long this will take. It's already down to 70 degrees, so it's not going to be too far away. Actually, I need to unload the filament before I can do this. It's unfortunate, so I have to wait a bit longer. So I can't do this with loaded filament. So yeah, so let's get this off the build plate. And we will figure the new nozzle, which one it is. So this was the 0.4 default, and I want to find the 0.4 high flow. Where is it? 0.4 high flow. Here it is. it has a little different, it has a different color. Still, I think it is not, is it hardened steel? Yeah, it is. So this is the high flow Revo hardened steel nozzle from Bondtech. So we have to set those parameters. We have to set it to high flow and hardened steel. It's a 0.4 version. That's what we're gonna swap it out for. So we have to wait for the unloading. Is it done already? No, not completely done. Okay, so the filament is unloaded. The nozzle, unfortunately, the nozzle is hot again. Only way to accelerate the cool down is using the spray here. Maybe we can accelerate this a bit, just from here. Not sure if this is working. Could work. Are you not cooling down? Oh, it's still heating. Oh my goodness. Cool down. Please do it. Come on, cool down now. Yeah, it's a bit faster. Yeah, excuse my impatience, but I want to get this done. And I really want to get going with the new nozzle. Let's raise the Z-axis a bit. So a bit more working area here under the printer. Nozzle. So let's go to 150. Okay, so cool down, please. So this should be now back to 70. I can probably use the gloves now and get it out. Once we reach 60-ish, and it's fine, and I can swap it. So swapping the nozzle is easy. Just unscrew it and see how easy that was. It was just a little notch here, and it's already released, and now we just have to screw it out completely. Go, go, go. The thread is pretty long. And we're done. So this is why, you see, this is why we probably want to put plastic repellent paint on here, because the plastic is going to stick on the brass. I'm not sure if the new nozzle has that kind of repellent on? Probably not. That's why for long-term printing, I would say is this probably the way to go, to have the plastic repellent. And we're now screwing in the new nozzle. Now, my guess is that we should just go very safe and repeat the first layer test, right? Not sure how precise this, like how precise the distances are going to be with a new nozzle, right? So probably want to do mesh bed leveling. I guess live is just mesh bed leveling. Is this bed level correcting? Bed level correction? I'm not sure. Mesh bed leveling. I think mesh bed level was the thing that we missed in the beginning, right? The plastic is actually super sticky to the nozzle tip. Yeah, need to figure out how to clean it. Time for liquid nitrogen, yeah. That's actually a good one. That's fun. So we're doing one more time, we're doing this calibration, because I think I didn't do it when I changed the sensor height. And then we want to repeat the first layer print test, the Z offset. I'm not sure if this changes every single time you swap the nozzle. It's probably this is actually something that is unavoidable, but yeah. Okay, so bed level correction, calibration. I think calibration is not the first layer calibration. Yes. Should we go with the original value? Should we risk it? I think we can risk it. I mean, how much of a difference is this going to be? Hopefully not that much. Filament is in the sensor. Okay, let's load it. And nozzle is heating up. And one last thing that you need to do is setting the high flow nozzle value and also the... I'm not sure actually what that changes, why there is these two different values, like the high flow nozzle value and the hardened steel nozzle value. It's probably, maybe it's pit values or something is behind it. Not sure what the actual purpose is. So far, we're doing good. Loading the filament. Let's go. Is it working? Yeah. So any moment we should be extruding again. Yeah, filament is extruding, it's working. Yes, color is good. Okay, so let's calibrate. Let's use the original value. Do you want to use the current value? Yes. Okay. So let's see if we can still use this original distance that we had. hope that we're not gonna scratch the surface, but I'm trying to be quick once there is any issues. I'm trying to raise the nozzle quickly. I guess this is going to work, but I mean, how safe can you be? I don't know. So we're still heating up here, but we are almost there with the bed temperature, 60 degrees. And that's probably good first doing a calibration before it starts. Is it? Yeah. One of the next things that I want to try on this printer, once we have done our maybe speedboat racing tests, and I think one of you mentioned that, I want to go to the using the 0.2 millimeter nozzle on this printer, actually, to printing some minis. And then seeing the different results from different printers in printing miniatures is definitely something I want to check. I'm interested in like the board game topic generally, so I'm really interested to see how this printer is going to perform printing miniatures. So definitely on my list of things to do. Okay, so we are starting. Let's see. How are we doing with the distance? Is any different? Not really. Actually, looks like we could actually go a little bit lower. But let's see. We could actually go lower. So you see, there's minor differences between different nozzles. Again, on this side, it's sticking. It's actually squeezing a bit more. Here we are further apart from the build plate, but overall, maybe it's not even a huge difference. Yeah, I think I wouldn't change it now. Gonna wait for the little square so we can see like how easy are the layers coming apart, but here, from what I can tell, it is squeezing quite well to the build plate. Let's see. It's going to print this little test square, so which we can see how good are the layers sticking together, and then we can. Once this is done, we are going for the next speed test. And I'm thinking about what value are we going to start at. Probably 20, right? We got 22.75 as the limit, so why don't we start at 20 and then see how far we can go? Like probably just targeting, I don't know, 35 We can also go for 40. It's probably gonna fail a bit earlier, but we could set the limit higher. So this is actually sticking quite well. I think this is good now. And I think this is what we wanted in the beginning. We wanted the layers not to come apart when pulling. So we have a really good, solid first layer. And that looks actually much better. I think I should have gone a bit closer in the first place. Good. So let's set the values on the printer now. We have hardware settings, printhead, nozzle hardened and nozzle high flow. Whatever that changes for the printer, I have no idea, but I just changed that. And now in the calibration settings here, going for a max flow rate test. This time we're going to start at 20, we're going to go for 40, and again putting this on stick, because this is not, of course this is not capable of connecting to Prusa, but we can just put it on the USB stick, print it directly from there, save the file, and extract here. And that's actually a nice little detail about the Prusa printers. Once you insert the USB stick, you're gonna immediately get the question whether you want to print this. Right, so just confirm and it's going. Now I'm really curious, like how much of a difference is this going to be? So it's the exact same printer, same filament. The only difference is it's a high flow nozzle. And we had 22.75 cubic millimeters maximum setting for the standard nozzle, which is already pretty high. For that kind of printer, it's, I'd say, pretty impressive. You need an API key from printer to make connection to Orca. Yeah. Maybe I should figure out how to do that. It's the Prusa Connect key, right? Yeah, we should try that at some point. For now, it's fine. But yeah, good information for me that I can actually try that. I wasn't aware like how it actually works with Prusa printers in terms of Orca slicer connection. But since Prusa is pretty open to like not hide their APIs or like close down the printers in any way, it's probably very reasonable that this is working, or like should be working, yeah. Fine, okay. So are we starting? Yes, almost there. It's almost starting. The bed temperature seems a bit low. Maybe that's also one of the reasons why there's not so much stickiness. I think we should go a little bit higher. Maybe going to 60 degrees bed temperature. I think Prusa even has a bit higher values, but yeah, let's see. Maybe just in case, I'm just gonna go higher with the, okay, let's change the heat bed, 60. I think the original Prusa settings are like 60, 65, even for this kind of build plate. Maybe that's the reason why it's not that sticking that well sometimes. It's just the temperature is a bit too low. So I'm going for 60. Maybe that's helping a bit. If that's in any case trying to detach. Hope not. That's probably not the worst thing to do here. I mean, I can't wait to see this happening, my friends. Let's see. I'm really so curious. Like, we're starting at 20 cubic millimeters per second. And my guess is that this is, we have a lot of headroom. I'm taking some bets from your end. Like, how fast do you think is this going to go? When is it going to fail? Make your guesses. Okay, so let's make a poll. Actually, let's do a poll on Twitch. We still have time. Let's open a poll. How fast will the printer let's say 25, 30? I don't know. Let's go for 32, 34, 38, 35, 38. Higher. Okay. I'm gonna vote for 3 minutes. So a couple of you are voting for 32 already. I'm curious, what do you think? How fast will we go with this Revo high flow nozzle? Are we actually going over 30, or I guess we are going to reach 30 at least, and maybe a bit higher. I'm not sure how much higher we can actually go, but there should be some headroom. So the voting is up on Twitch. So if you're like on the Twitch mobile app or in the Twitch browser app, you will see the voting in the chat popping up. So just go there, like, vote what you think, how fast we are going to go. When are we going to fail? My guess is I'm probably like a little bit more careful. I would say 30 is where I would see it failing. Let's see. I see, we need an API key for connecting to Prusa Link, authentication API key, and password generated from printer. Okay, I'm curious how complex the API key will be. Let me see, settings network Prusa Link. Okay. Probably not available here. Okay, let's do this when we're done with the print. So I'd say once we have figured out the maximum value, then we'll call it a day. I'm going to bed. I need some sleep now. Speed benches will follow for sure, but the tuning will take probably a bit of time. And so I can post you some short videos if you like to give you the progress that I will have throughout the week. Actually, let me look at my calendar. What's happening? Like, I think is this week? Is it already this weekend? Is this weekend already no. Next week. I'm not sure. When is the date? Let me check. Was it the 12th? I'm missing a calendar entry, to be honest. Next weekend, not this weekend, but next weekend, we're gonna be at the Chaos. We're gonna be at the Chaos. I'm going to be at the Chaos Drucker event. So basically it's called Stammtisch, which means we're meeting in a restaurant. But there is also a kind of a huge area where we can put some printers, run some printers, and have some nice discussions. So I'm really looking forward to this. It's going to happen next Saturday. A nice meetup for printer fans. So we are already at 20 cubic millimeters per second. That's the starting value. And I will keep you posted where we are at. If we want to reach 30, we need to reach at least, we need to reach 20 millimeters. All right, so that's gonna take a couple more minutes, but let's say technically, yeah, we need to reach 20 millimeters to have additional 10 cubic millimeters on top of the 20. And so, yeah, let's see how far it goes. It's already pretty fast. So we will be at the original, like we will be at the limit of the normal nozzle when we reach, let me see, when we reach around about 5 millimeters, it's gonna be there, and it's like we're gonna be at 5 in a second. It's gonna be like 5.5 maybe something. Well, this is gonna be the original limit. Now we are at 4. Right, so not so far away actually. So now we're at 5 millimeters. That means the 22.5 are already passed. And with the last test, we probably reached clicking the limits of the extruder, and where it was starting to click round about now. But I don't expect this to happen so soon. So once we reach 10 millimeters of print height, we will have 25 cubic millimeters per second. Yeah, it's still going faster. Still going faster. Not sure about the printer's internal limitations. What are the technical limits of the printer in terms of print speed, or what are the settings there. We have to check once if we really hit a technical limit of the firmware or something is set to be limiting the printer from going even faster. But so far I can tell it's still going faster, it's still accelerating. So we're almost there at 10 millimeters. That means we're like at 25 cubic millimeters per second extrusion. Okay, so at 11, I hope that the printer is actually now going faster. I think I can tell that it's still going a little bit faster, just from the noise pitch level. Not easy to tell actually. I think Orca Slicer should remove all of the speed limits for this specific test. It's going to change a lot of settings within the printer. I think it's also like removing all of the limitations, setting everything to crazy high values. So extruder 1. I'm not sure like where's the settings for speed. I think there's a top speed limit somewhere. Where was that? I think it was it part of the basic information? Nozzle type, machine, extruder, motion ability. Yeah, the maximum speed limit is 400 millimeters per second, so I guess. But I think it's still going faster, right? I mean, eventually we will hear it, because if it's not starting to grind at some point, then we'll definitely have an issue with the print speed settings. But I think it's still going faster. I'm not wrong. Sound is still pitching up a bit. Oh, it's definitely going higher. It's definitely still changing. So, my friends, we are reaching 19 millimeter. That means 1 millimeter is missing to the 30 cubic millimeters per second. Still accelerating. I can still hear it's getting faster. We are at 20. Oh, and that was the first clicking noise. Exactly at 20 actually. Now it's becoming, we see the issues coming already. Like there is not sticking anymore here. But it's, maybe that wasn't actually the extruder. It was the part coming loose from the, it was actually releasing. So, false alarm. It's going to look terrible, I know, but it's still sticking here. So, unless we see issues on this side where the print is still sticking, I guess we're good. That's unfortunate. It's detaching here, so it's going to look terrible. But it has nothing to do with the print speed. Actually, it's more like the adhesion for this kind of print. If it's a super thin first layer, it is always an issue. We're still going faster. Actually, we're still going. Probably gonna swap over to this side. And we will take a look here. What value are we at? We are at 24 millimeters. Still going faster. Is it grinding now? Let me touch. I think it's now grinding. Definitely grinding. Or is it just releasing? Yeah, sounds like. I mean, can we force it even faster? That's the question. It's going at, what is it? 33 cubic millimeters per second. Yeah. Extruder is struggling. It's definitely struggling. Okay, I think we can stop it here. It's probably gonna fail in a second. Not gonna push even. Yeah, so we were, I think, like when we reached the 20, I couldn't exactly tell you if there was a grinding of the extruder, but I would say the first click, the first crack was actually the part detaching, but I would say like 20-ish, 20, 21, 22 even, but then it was really like, it was clearly the extruder. So at like 30, like probably repeating this test with even better proper adhesion, just giving it a second test would tell us the exact number. But for now, I would say we're safe, very, very safe at 30 cubic millimeters, very safe. And we can just use that as a starting value for the next test and just see where we, like how far it goes from there. So I'm gonna save this to a new filament setting. It's okay. This is the ESUN EPLA blah blah blah. We're gonna save a value of 30. Say this is my safe value. It's not bad. It's really definitely a huge increase. And maybe we can push it even higher. And we didn't test other filaments yet, so maybe the Creality Hyper PLA is a bit better. We can test that. Different filaments. I mean, this is a completely different thingy. So eSun, ePLA, HF Revo, I would say high flow. Yeah, so this is a different nozzle type, and so we need a different setting for that. So that's our best value so far, 30 cubic millimeters and maybe even higher. So that's something for another video and maybe an update throughout the week. Thank you for watching. I definitely need to get some sleep. Thank you for watching. Thank you for coming and for your interest. I hope you had fun watching this live stream. I had fun, definitely. I had very much fun just building this and swapping out the whole extrusion system now for a Revo. It was pretty straightforward, I would say, very successful, and the results, I think the results are great, but to be seen. We want to print more stuff with it and then pushed all of the settings for the slicer, figuring out what are the actual limits and how far can we go with the acceleration values and all of that, and really pushing the Benchy times down to, I don't know, maybe we can go, I would don't make any predictions, but below 20 minutes is my first goal, of course, and the highest value that I had so far with my V100, I think we were around about 16 minutes or something. Anything that is significantly below 20 minutes is already a good start, and then we can push it even further. So see you very soon next week, and have a good weekend, have a good relaxing time until the end of the week, and keep on printing, my friends, keep on printing.